Second half of class. Next class. Second half of class.
Oh, yeah, that part's wrong. I didn't. Bottom left. Yes, it's second half.
Oh.
Second half of this class.
Correct.
Okay, that's not, I was curious. I saw that. Next class, this class.
Yeah, sorry, that's my fault.
Trust. You're good.
I changed it one place and not the other.
Oh, good.
All right, guys, I need y'all to get out your number 21 bookwork. Sorry, the internet's not working here, so I can't update that on the right. But it's been a little bit since I've seen you guys, since last week was an A week. But reminder here that we've got the first half of class for you guys to ask questions from the book assignment and to study. And then we will take that quiz the second half of class. Mason was here. Okay. So I will help as much as I can during the first half of class. So whatever book questions, girls, I can't be talking now. I'm not going to talk over you. I'll take whatever questions you have that I can help with the first 45 minutes to make sure that you've got time to still take your quiz the second half of class. But of course, some of the questions that are going to be asked may not be ones that you need help with. So take that time to look over your other questions. Again, this section we don't do a practice quiz, but that doesn't mean that we are trying to hide what we were going to quiz you over. Just looking at the questions, 9B, 11A, 15 are all the same type of questions, so there's probably one of those.
Oh, so I'm late. We for student council, we're selling sweatshirts. I had to clean that up.
Okay. Then in the future, I need an email. If someone's asking you to say, they need to send me an email, or it's not important. Then questions 19 through 22 were the same, so probably should expect at least one of those on the quiz. 33 through 36 were the same. There's probably at least one of those on the quiz. 47 through 54, all the same type of questions. Should expect at least one of those on the quiz. So the quiz questions come from the book assignment. Same type of skills. Which questions from the book did you have issues with that you would like me to go over before we go to the quiz?
Just like one little thing. So, you know, theta? What's the little dash mark next to it?
Theta is the original angle. So, oops. This could be theta. The reference angle we usually call theta prime.
Okay, so we're trying to find theta prime most of the time.
For questions 47 through 54, you're trying to find the size of the reference angle.
Okay.
Like we did the back page of your notes. Yes.
Can we do question 36?
36. Okay. Everybody else, just check 36 real quick. Again, if this is not one you need help with, just use a couple minutes to review your book questions. But this one says, take a point on the terminal side of theta given the specified quadrant. So we want something in quadrant 4, so do not do anything in 1, 2, or 3. We need to take a point that's on this line. So this is why we talked about in the notes. If we want to graph this, you probably want to put it in mx plus b format. So solve for y equals. Then you can see the y-intercept is 0. You can use the slope to count rise over run so that you get a point. And then if you take this point, draw it to the x-axis, that's where your reference triangle comes from. And if to get here, I went right 3 and down 4. You can count that as two sides of your right triangle. Pythagorean theorem or Pythagorean triple to figure out that this is 5. Hypotenuse is always positive. X could be negative if it's going left, and y could be negative if it's going down, but the hypotenuse is always positive. And then looking from the angle at the origin, it wants all 6 trig functions. But now we're left with SOHCAHTOA. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And if it wants all 6, then give the reciprocals too. Okay, anything more specific on that one? Anybody else that was going to ask this one have something more specific? I guess I don't like to give y'all any unfair knowledge about the quiz, but this type of problem is on the quiz, and the only reason I'm saying that is because it does matter if you pick a point in quadrant 4. I tried to say that my 8A classes had to take this last Friday because they were ahead because it was an A week. For whatever reason, when you graph that line, sometimes people just ignore this part of the directions, pick a point in a totally different quadrant, and if they show enough work, I can give some partial credit, but that's a silly point to miss. If it says take a point in quadrant 4, make sure you picked a point in quadrant 4. Yeah.
Can we do 93B?
93B, okay. 93B says secant of some angle is 2, and it wants to tell me it wants me to find 2 solutions, both in degrees and radians. Okay, well, when we memorize the unit circle, do we memorize secant values?
No.
Okay, but I could change secant to be what?
Cosine.
Okay, so if I take the reciprocal of the left side, to keep it balanced, I need to take the reciprocal of the right side. So this is like a backwards unit circle question. Instead of telling you what angle to go look at, I'm telling you what the ratio is, and you got to tell me the angles. So as you go around the unit circle, when is cosine a half?
Oh.
30 degrees cosine squared of 3 over 2. At 60 degrees, it's a half, which is the same as pi over 3 radians. And then where else is cosine a half? There's 2 answers. There's 2 answers in one rotation.
Is it the fourth quadrant?
Okay. Fourth quadrant?
Yeah.
Up here?
Yes. There and then a little lower. So like 330 degrees and yeah, and then the other one would be
300.
Okay. Is cosine the x values on the unit circle or the y values? Cosine's the x values. The point that has the same x value, you can actually visualize that as the one down here, not the one up here. So that's not 330, that's what angle is this? 300, which is the same as 5 pi over 3. So the first step's the most important, because if that doesn't cross your mind, then just take the reciprocal of both sides. You don't memorize secant values, so that would be very hard, but when you memorize the unit circle, all of those x values that you're memorizing is cosine. So they're wanting you to identify when is cosine a half. That would be the 2 times. The 2 times within one rotation. Okay, to try to keep this balanced here, let me give people a chance who haven't asked a question yet. So anybody who's not asked a question have one? 39? Sure. 39 is actually just a unit circle question. So I know that because as soon as it says an angle that I know on the unit circle, you can go to that spot. You can think of the point there. Cosine is the x answer, sine is the y answer, and if you want secant, then you should be taking the reciprocal of which one? Okay, and the reciprocal of 0 is undefined. So we could have given you that exact same question in section 4.2. And in fact, in 4.2, we just make you find all 6. What's the sine at 3 pi over 2, the cosine at 3 pi over 2, tangent at 3 pi over 2. This just wanted one of them, just secant. So still unit circle. All right, somebody else who hasn't asked one yet?
Can you go over 25?
25. Okay, so they tell me my angle is in quadrant 2. So again, I don't know, maybe if you felt rushed for time, you might miss that, but when you guys have an extra time on a quiz, you should be double checking these things. Quadrant 2. Here's my triangle. Now the 0.6 bothers me, so I'm going to change this to a fraction. What is 0.6 as a fraction?
6 over 10.
Okay, 6 over 10, which reduces to 3 over 5. So if we're looking at this angle near the origin, and sine is opposite over hypotenuse, that gives you 2 of 3 lengths. And to me, now this is not much different than the first 3 questions. The big thing, though, that you need to be careful about is if you know your Pythagorean triples, this could be a 3, what, 5 triangle.
3, 4, 5.
Okay. Also, if you do Pythagorean theorem and you solve it, you're going to get 4, right? 4 is not what you should call that length.
Minus 4.
Negative.
Because it's going to the left, you have to make it a negative 4. So it's not that Pythagorean theorem's wrong, it just doesn't know what direction you're wanting to go with it. Same with Pythagorean triples. Now if you want all 6 trig functions, okay, they really gave us this one. So if I only needed cosecant, I guess I could have skipped a picture. But now that I've got the adjacent side, I could do cosine and his reciprocal, and tangent and his reciprocal. Is that good enough? Okay. I'm still going to plug one more time. Even though you don't have to use the all students take calculus for this question, it's still helpful to you, because if it's supposed to be in quadrant 2 and the only things that are supposed to be positive in quadrant 2 are sine and its reciprocal, when you're finished, if sine and or his reciprocal is not positive and the other 4 are not negative, then you should rethink your work. So I can see why you might miss that 4 is negative originally, but if you take that 5 seconds of work, you should realize those answers are supposed to be negative and to reconsider before you turn them in. Okay, Ramiro, did you have one? Number 50. Okay, 50 is a reference angle 1. This was a big part of what we talked about in our notes. So, in our notes, we sketched a picture, and in your homework, it asked you to sketch a picture. I think in our quiz, it does not tell you to sketch a picture, but I would still recommend it. Doesn't have to be super accurate, but you better put it in the right quadrant. So here's where 0 degrees is. Going this way, this would be negative 90. This would be negative 180. Negative 215 is somewhere up in quadrant 2, and that's good enough for us. Take this point on the terminal side of your angle, draw it to the x-axis to create your reference triangle. And this small positive acute angle is the reference angle. That's what we want to know the size of. So if you know that this was 215 degrees of a turn, I could see that this much of it is not the reference angle, which I happen to know is 180 degrees, and then that leaves behind how much the reference angle should be, 35. Reference angles should always be acute, and it's always positive. Reference angles don't care about direction, that's why they're always positive. But it's still good to check for acute. If your answer is bigger than pi over 2 or bigger than 90, there's no chance it's right, and try again. And if your answer is negative, there's no chance it's right, try again. Okay. Anybody else who has not asked a question have one?
53.
53. Okay, so same directions, but this one is in radians. And this one's a little hard to do without a calculator, but here's what I would do. I know this is 0 radians. Halfway around is pi radians, but pi as a decimal is about 3.14. So if I double that, 2 pi is about 6.28. Again, I need to sketch this to know which quadrant it's in. If I put it in quadrant 2, but it's actually in 3, then my answer's not going to come out right. If I put it in 3, but it's in 4, my answer's not going to come out right. So is 4.8 closer to 3.14 or closer to 6.28?
3.14.
Okay, I'm hearing 50-50. So here's how we can figure out what 3 pi over 2 is as a decimal. You okay with where these decimals came from? Okay. Well, it's going to be exactly in the middle of 1 pi and 2 pi. So if I add those together, that would be 9.342. And then divide that in half. This would be 4.5 plus 0.2 plus 0.01. So 4.71. I'm just taking the average of these two. So 4.8 lands in what quadrant? 4. And it was real close, and that's why that's a tough one to figure out. But again, I just took the average of 3.14 and 6.28. I added those up and then divided in half. And I did it in parts, so I could do it without a calculator. Okay, all that to figure out that it's in quadrant 4. So here's the reference angle and the reference triangle. I would probably say all the way around is 2 pi. And the amount of that distance that's not the reference angle, all of this stuff is not part of the reference angle. This stuff is part of the reference angle. And I happen to know how much all of this stuff is that I don't want. It is 4.8. There's your answer. There's no need to put that in your calculator and round it. The directions didn't say round. So don't do more work for a less accurate answer. This is an exact answer. Okay, so I feel like that one's a little tougher. But is everybody okay with why it landed in quadrant 4? And where the answer came from? Okay. Give me just 1 second. I need to make sure I know what our cutoff time is. I know we still got time, but... We need to start at 20 after, so that still gives us 27 minutes. Okay, another person who hasn't gotten a question yet?
52.
Sure. So 52, still in the same set of directions. So if we tried to figure out what quadrant 7 pi over 6 lands in and give ourselves a decent picture. Well, this is on the unit circle, so if you have the unit circle memorized real well, you can kind of skip this. But I know where 1 pi over 6 is. It's 30 degrees. So if I add it again, here's 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, which reduces to pi, and then 7 pi over 6. So draw that up to the x-axis to get your reference triangle. Here's the reference angle that we'd like to find. And so you need to just use some of the angles that we are given with some of them that we know. I see that I just turned 7 pi over 6. But most of that's not the reference angle. All of this stuff is not the reference angle. And I know that stuff makes up pi. If I get a common denominator here, 7 pi over 6 minus 6 pi over 6 leaves 1 pi over 6. So the way I counted that, I probably could have caught that answer earlier without the picture. But as I was counting, I said here's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and then I went 1 more pi over 6. So that's how much that was. Okay. Anybody else that has a question that hasn't gotten to ask one yet? Okay, then open it back up to those of you that have asked. What are your other ones that you have?
Since we won't use the calculator, we don't need to do like 79 through 81 on the test, right? With those questions.
Those type of questions could be on there, but we would phrase them like multiple choice. Like, how would you put this in your calculator?
Oh.
But yes, that's a good observation. Our quiz is no calculator. So the questions that are straight calculator questions, obviously, I'm not expecting you to just do that in your head, but we would phrase it in a different way, so you wouldn't need a calculator. Yeah.
Could you walk me through 31?
31.
I got tripped up on the undefined.
Okay, well, what does this mean? If theta is this, what is this trying to say? Okay, so it's bigger than pi over 2, but less than 3 pi over 2. So theta is somewhere over here. And then the other clue they give to you is cotangent is undefined. Well, do you know where cotangent is undefined here?
Line 0, no, it should be -1, 0.
Okay, how did you know it's undefined there?
Because tangent would be 1 over 0, or no, it'd be 0 over 1, that's 0, right?
But I don't know anything about tangent. I know something about cotangent.
It would be 1 over 0.
X over y. So -1 over 0.
Okay, that's a good way to think of it, sure. And that's perfectly fine. I think for most people, probably the quickest way is to think of cotangent as cosine over sine. So when is cosine over sine undefined?
When sine is 0.
Okay, and then so through all of this, there's only one place where sine is 0. It's at pi.
So pi would be the answer.
No, pi is the location. It wants to know all 6 trig functions. So you know cotangent is undefined. That one's given to you. But what is this? What's the rest of this point?
Oh, 1, 0.
You go right 1 to get to that point.
Oh, well, -1.
So that means cosine is,
-1.
and secant is just his reciprocal. Sine would be what?
Sine would be 0.
And so his reciprocal would be,
Undefined.
just can't divide by 0. And it doesn't really make sense to try to do the reciprocal of undefined because you can't do that. But if you've got sine and cosine, sine divided by cosine can get you tangent. But that's a hard one to find the location of. But this is telling you to look in quadrants 2 and 3, or bigger than this angle, less than this angle. And if you think of cotangent as cosine over sine, he has to be undefined when sine is 0, because you can't divide by 0. And there's only one place where sine is 0. As soon as you find that place, that point unlocks your answers. Yeah, Jonathan.
We do 50. I think like a simple one, but I should make that time.
We already did 50.
We did.
We did. Okay, other questions?
Could you, so I'm just referencing just minus everything by 180?
180 was the part of that 215 that's not a reference angle, so that's why I subtracted 180.
Are you gonna tell us what the reference angle is in the quiz?
Am I going to tell you what the reference angle is? That's the whole point of the question.
Oh. That's not a stupid question.
No, we won't draw the picture for you, nor will we show you where the reference angle is. And we certainly won't give you the size of the reference angle because that's what we're going to ask you to do.
Okay.
Yes, Ramiro. I'm sorry? 54. Okay, 12.9, and it doesn't say degrees, so we have to assume that's radians. So we got to spend a couple minutes here trying to figure out what quadrant this lands in. So I know this is 0 radians. Go halfway around, you get to pi radians, but I'm going to think of that as a decimal because this is as a decimal. 2 pi would be 2 times 3.14, or 6.28. If I add, actually, if I just double that to make 4 pi, this would be 12.56 radians. Are you okay with where I'm coming up with that? Okay, so what it's doing is it's going all the way around once to get to 2 pi, 6.28, and then it's going all the way around the second time to get to 4 pi, about 12.56, and your angle is supposed to be 12.9, so I can confidently say that goes up in quadrant 1, but that's not big enough to slip over into quadrant 2. So here's your reference triangle, here's your reference angle. And what I realized with this angle is this whole turn, when I went all the way around, and a little bit more, was this. How much of that turn was not this reference angle though? 2 pi is just this, just one time around. I've got more than that. Sorry? 4 pi. This is not part of the reference angle, and the second rotation was not part of the reference angle. So of that 12.9, 4 pi of it is not the reference angle. So minus 4 pi. Once again, no need to put that in your calculator in round. Unless the question says round, you should not be doing that.
Can you do
22 wants to know when is secant positive and cotangent negative. Okay, so for me, I like to make 2 little charts here. I use the All Students Take Calculus as a quick way to do this. It's not the only way to do it, like we talked about in your notes, but it's a pretty efficient way. So you have to remember A is for all are positive. S is not just for sine is positive, but sine and his reciprocal. Quadrant 3, tangent and his reciprocal. And quadrant 4, cosine and his reciprocal. So secant has to be positive in 1, because everything's positive in 1, but also in 4. Reciprocals doesn't change the sign. Flipping a fraction over doesn't change the sign. So based on this clue, your answer either has to be in quadrants 1 or 4. And then this clue, where's cotangent negative? Well, that can't be quadrant 1 because everything's positive. And where else is cotangent positive? Okay. This is where tangent and his reciprocal are positive. So if you want to know where he's negative, it can't be that one. So based on this clue, it has to be 2 or 4. So the only quadrant that both of those are true in is the 4th quadrant. Okay, anybody else gonna ask about 22? Wanna say anything before it goes away? Okay, we still got about 15 minutes if you've got more.
Can you go over 33?
33. Okay, we need to pick a point on this line in this quadrant. And then once we get that point, it'll be like the first 3 questions in your assignment. So we need to be able to graph this guy. Y-intercept of 0, slope of -1. I need to take a point on that line. So what's wrong with picking this point?
Oh no.
It has to be.
Oh, it has to be quadrant 2.
Right, they said pick one in quadrant 2. So going this way, you can pick any point on this line. You'll get the same answers, but just for simplicity, I take the first point. And to get to this point, if you're going left 1 and up 1, that's like, 2 sides of your triangle. You could do Pythagorean theorem to find this side. And then looking from a reference angle, sine could be opposite over hypotenuse and rationalize. Cosecant would be hypotenuse over opposite. Cosine is adjacent over hypotenuse, which needs to be rationalized. Secant would be hypotenuse over adjacent. Tangent would be opposite over adjacent, and cotangent would be the reciprocal of that. Since we're in quadrant 2, the only answers that should be positive are sine and his reciprocal. The rest are supposed to be negative. Now this one should kind of make sense, right? If the slope is -1, do you see how it's going exactly in the middle of this quadrant? And then on the unit circle, when you're exactly in the middle of that quadrant, what is sine and cosine?
-1,
Except cosine's negative, so you see how you get the same values?
Okay.
But you don't have to make that unit circle connection. It just, if you see that, those answers should make sense. That only works because this goes exactly in the middle of the quadrant. Okay, I'm gonna leave the screen on, so as you guys find anything else, you're welcome to call it out or raise your hand. You still got about 13 minutes before we need to move on, so. If you have other stuff, I'm willing to help. It seems like you might be running low on questions.
This one right here. So
Cosecant is bigger than 0. Tangent is smaller than 0.
Okay.
If I do this correctly, I have to take this one apart too.
So cosecant's positive when sine's positive.
Yeah.
So that would be 1 or 2.
Mm-hmm.
Tangent is
Negative.
positive at 1 and 3. So he's negative.
Wait. Tangent, does that say negative?
Yeah, I know. But I know
Oh.
he's positive at 1 and 3, which means he's negative at 2 and 4. So 2 makes both of those true. Quadrant 2.
Tangent negative can't be here, and then can't be here.
Mm-hmm. So that means it's
But
the
it
other 2.
can be here. Okay. Alright. So I forgot how to do this like last time.
Yeah, I kind of wonder if it's better that y'all, like my 8A class had less time between their quiz, so y'all had more time to do your homework and such, but then
Yeah.
also more time to not think about it. I don't know which one's better.
One more question for you. So on 97.
So we're going to the last one here about the airplane.
Mm-hmm.
It asked about C equals 120. Wouldn't it be over here?
Well, it wants you to do 3 questions. Part A, if this
Right.
was 30, solve for D.
Wait, so I did that.
I think it's 12 miles.
So it's 12, 6, 12.
Okay, and then if it was 90, it would be right above him. So
So
that
it'd
would
be
be 6.
six.
So we don't really need trig for that. And then if the angle was 120, it's not 12.
It's like 12.794.
Yeah, something like that.
12.94. Okay. Alright, I was just curious.
Yeah, when I typically just redo the picture, like if the angle's 120, if this is 120, what they're hoping you see is that
Yeah.
when you do this, you can make a reference triangle over here, and how big would this angle be?
That'd be 100.
If this is 120, then this has to be
60.
60. Together they make 180. And then you know this guy is 6 miles up. So when you do the sine at 60 is opposite over hypotenuse, this ends up being your exact answer.
Yeah.
Because 60 degrees is something we memorize on the unit circle, we could replace that with square root of 3 over 2. Dividing by square root of 3 over 2 is multiplying by 2 over square root of 3, which is like 12 square root of 3 over 3, or 4 square root of 3. That would be the exact answer. For our brains, though, this would maybe be where I'd want to see it as a decimal. It's about 6.928 miles.
Thank you.
But that's what they're wanting you to see. Even though this angle is 120 and it doesn't match up with the picture, the sine of 60 degrees and the sine of 120 degrees are the same. And that's where reference triangles kind of play into that.
That's what I thought.
Okay, we need to start in about 5 minutes. So feel free to use 5 more minutes to study. This is 5 minutes. Second half of this class. Yeah, I have to take that to hard copy. I think
You don't need to say it. I didn't see a spot. I shouldn't turn it in.
you'll turn in the hard copy
Alright, you're doing it right now, actually.
when we start in a few minutes.
Get it safe, do it.
Yeah, I will take up the homework in a few minutes when we start. I didn't bother making a place to turn it in the Google Classroom because I suspected you'd have a handful of questions. That's why we gave you the first half of class to ask questions. And I don't know. The only people who could have turned it in Google Classroom before class would be people who had 0 questions. And I just didn't figure that would be many people. So I'll just take up your hard copy before we start. But I will tell you all that in just a few minutes.
Do you have a stapler?
I do.
It's fine. Yeah.
I did.
Somebody take it.
Hope not. It's the only one I have. Question?
I just need to paper.
My name on it? I don't know.
I still have a couple minutes. I'm gonna give all the directions in a minute. If y'all are turning it in now, that's fine, but make sure you hear the rest of the directions in a second.
Stacy now.
Okay, we need to move that direction So if you did not hear a minute ago, I do need your homework before we get started here. There's not a place for you to turn in Google Classroom. I said just a minute ago why I didn't bother with that, but all I need to do is check them so you can still get them back at the end of class, and I'll let you know where that is. This is a no calculator quiz, so you need to clear off your desk. And before I get you your quiz, you need to put your phones and smartwatches up on the side of the room. So get all that sorted out, and then I'll let you get started.
Alright, you should put your name on this. And I suggest you number it as 22 so you know where it fits in your binder when you get it back. And y'all are a little bit different spots with A-Day. A-Day had to take it sooner, so they had less time to do the homework, but they also didn't have the weekend to not think about it, so I don't know which one's better there, but I would say that A-Day, I think for both classes, the average was around 90% for this, but there was a lot of almost perfect papers where it was just really, really, really small mistakes, like not reading the directions carefully or whatnot, so just a heads up so that maybe you will make less of that type of mistake. Give me just a few minutes and I will set a timer on the board for our dismissal, and then that's when you have to have your quiz done. I changed the front screen, so feel free to take all second half of class. sorry to interrupt here, but after you guys turn your quiz in and you come over here to get your phones back, your graded homeworks will be right here on this chair. If you would, please go to the stack and find your paper and take it back so that you have it in your binder. Also, there was one with no name on it, so I didn't know who to give credit to on that one, so. You should also be looking at them to make sure that's not you. This- At the fastest there, and you sign out for it. Sorry, yeah, I'll leave a marker over there. Thank you.
if you finish early and you're sure you've checked everything that you can, you still need to find something quiet to work on till the end of class. Thank you.
These are data, and this is the data from.
The size of the data frame. Thank you.
If we wanted you to tell us what other people do in the calculation, how would we do that?
Okay, if you're still working, down to about 4 minutes.